Okay, so how is everyone feeling? I was feeling a little tired. The room's a little warm. So Susan and I thought a lot about this because we're ending out the day right now. So our goal is to be very transparent with you so you don't have like surprise 20 slides coming, and to give you a little preview of what our plan is. So after the last discussion session, we had a very dense and informative series of talks on little red dots. And so our first two activities are related to little red dots. And then I think for the second part, the umbrella that we saw connecting a wide range of talks, mostly focused at Cosmic Noon, was understanding systematics. So get ready. Okay, so little red dots. The immediate thought was, oh, we should just ask them what's a little red dot, but that we figured would open a whole can of worms. So instead, what we thought we would do, there's this beautiful artist's rendition of describing the physics of a little red dot. And so in this, you can see at the very center, you have the supermassive black hole. You have the broadline region coming out with the blue and explaining all the different parts. So we have these optically thick outflows you're seeing with this broad H alpha. And this idea, they call it a cool gas. I always thought that was a warm gas, but I guess that's all subjective, of this envelope, that it's in a cocoon of something like 10 to the 4, that gas that is needed to explain that Balmer break that we observe. And then the dust temperature is in this, if I understand correctly, this magic peak where we don't observe it in Miri and we don't observe it in ALMA. And that is why we haven't yet made those detections. So what we wanted to do, and Susan is going to take over here, is have you guys make and break, and we're looking for people to volunteer at this point, ideas for what do you think is right here, and what do you think, do you have any questions, things that are missing? Susan, do you think that captured? You have the mic too, if I go away from you. Okay. Okay, now you have to wake up because somebody's got to volunteer. I'll stare you down. Thank you, Harley. You got to yell. I don't know if there's a microphone. Does that sound good?
Yeah, so the first one is, at least for like the most extreme sources like Anna de Graaf's and Rohan Naidu's, the covering fraction has to be about 1. That's virtually impossible to avoid because if you have any reflected emission, you're going to beat down your Balmer break with nebular continuum. So this idea that you can have it sort of leaking off angle is kind of hard because the gas emission goes as 4 pi. So that's sort of the first problem. The second problem is it's not entirely clear to me where the absorption features are coming in the case of the Balmer emission. We see H alpha in absorption, H beta in absorption, and so you can put that at the same place as the dense gas cloud, but it doesn't necessarily have the same line width. So you'd almost have to, if it's gravitational motions, you have to see it perfectly edge on, which makes absolutely no sense. That would imply there's an entire population of ones you're seeing at a different viewing angle, which is highly improbable since LRDs are already fairly numerous and a huge fraction of them have the gas in absorption.
We don't have any more room for you.
Okay.
Sorry, keep going.
Yeah, it's also not clear to me why the iron emitting gas has to be separate from this dense cloud. It's the cloud's already at the right temperature, so to separate them, I mean, it makes a...
Sorry, so you're talking about...
The iron 2 emitting gas.
Okay, coming out.
I mean, it makes a beautiful picture, much nicer than one I can draw.
Yes, it is really a beautiful picture.
No, it's great. So the other thing is that I don't really understand about the BLR in particular is that the absorption in the Balmer lines is narrower than the broad lines, okay? But the Balmer break seems to require lower velocities than the BLR, but here it's drawn as if the BLR is outside that cloud. And so if the BLR is driven by gravitational motions, why do we have broader lines outside the cloud of gas that's causing the Balmer break? That would imply that you basically have rigid body rotation and your mass profile's increasing going outwards, which also doesn't make a huge amount of sense. So,
Do you think that there is anything correct here?
the color pattern?
The what?
No, I'm kidding. The color pattern? No, I think qualitatively it's a black hole with gas surrounding it. But I mean, these
Okay,
are really
good.
detailed numerical thing. Like these are very, detailed spectroscopic features that there's a reason why we haven't come up with a model, because it's extremely difficult.
Okay. I saw Pablo down here. I don't know if this is... Can I carry this? Okay. I'll just carry it like this. It appears to be okay.
So I'm convinced that some little red dots, that 5% that Guillermo said, are dominated by an AGN, by this picture. I'm not convinced that all of them are the same. But something that makes me very nervous in this scheme is that, well, I see iron there, but I know that these guys have oxygen, neon at least. They have metals. So
it's
there
missing
must be
more
stars.
metals.
You say there, where is the galaxy? But in the picture there is no stars. So there has to be stars, or the metals forming in a way that in
that would go
black
on the other
holes.
one.
In black holes that's not common knowledge so far, I think. So having I have a big problem with people that identify little red dots with AGN. There is something more there.
So we've heard.
Yeah.
Yeah. Okay, fair. So
Most
where
of
is the
them
galaxy?
can host an AGN. Some of them are dominated by the AGN in the emission lines in the continuum. Not all of them are the same, but there must be stars. And also, the proof are the metals that I said, also the dust that you mentioned. That's true. Some of them must have dust. So there
Okay.
must be stars.
Okay. We'll go Fabio here and then Guillermo.
Yeah, so I agree that not necessarily all the little red dots need to be with a supermassive black hole at the center. So in this picture, the biggest question, in my opinion, is really what's the mass scale of the black hole at the center? Because you can easily have a 10 to the 3, 10 to the 4, even 10 to the 5 solar mass black hole. You're not going to be able to see it unless it's accreting at very high rates. I am pretty sure that most of the red dots will contain a massive black hole at the center. It's really about what's the mass scale. If it's 10 to the 6 and above, you're going to see it, even in the X-rays necessarily. Even if it's 10 to the 4, 10 to the 5, you're not going to see it. So in that perspective, the real question is how big is the massive black hole at the center, because that would also drive variability, which is a topic that we haven't touched upon much. In my knowledge, there are 2 papers right now that they're studying like optical UV variability in little red dots. One is finding some variability on time scales of a few months, so only JWST data. The other one, using also HST data, is finding basically at 0.15 mag, if I remember correctly, while an AGN of 10 to the 6 and above would require 0.30 mag. And this is using also HST, so much longer time scale. So it's really about what's the mass of the black hole at the center. We should detect variability, especially in the X-rays at some point, if some of these are detected.
Thank you,
So
Fabio.
there's a black hole at the center, which is correct.
So now we've entered the speed round. In a few seconds, please
No, hold
tell
on. Well, Guillermo, sorry, I told Guillermo that sorry, I did
So
say
it
that.
feels kind of cheating because I already talked for 20 minutes, but let me just throw a couple of things
Get
in
10
there.
seconds.
Yep, 10 seconds, okay. I do think they are all
Speed
AGNs, or they all have AGNs. The matter is where they dominate the SED completely in all the ranges or not, but I do think like 90% of them have broad lines. They do have AGNs. I also think they all live in a galaxy, as Pablo was saying, and I think there's growing consensus maybe that the UV actually arises from the galaxy, and when you look at the low redshift ones, you actually see some structure in the UV, not in the optical because there's the point source, but you do see a structure, and they might live in a tiny, puny little blue galaxy, and then once you shut off the accretion, it kind of looks like a normal galaxy, so it might just be a phase, it goes on and off, it's just the early growth of the AGN, but I do think they all have AGNs, I do think they all have galaxies as well, so.
I don't know why I have both. I have two
Nice,
speakers.
Ben.
Okay, we're moving on, I think, aren't we?
Speed-
No, sorry, you're
speed
still.
round.
We're too. Okay.
And then we'll move on.
Yeah, I have a comment
Okay.
that's sort of facetious, but it's not really facetious, which is that there's a rule in Sloan that if you see a spectrum you can't understand it, it always turns out to be a broad absorption line quasar. So that's my guess, is that little red dots are broad absorption line quasars.
Good job keeping it to 10 seconds.
But also, I want to say one other thing, which is that sometimes in little red dot studies, there is an argument is made, which is it doesn't have X, so it can't be something. You know, like it doesn't have mid-infrared emission or whatever. And I think that's a little bit of a, we don't know enough about galaxies at this redshift to actually make that statement.
Okay, 2 words. Totally wrong.
Under break, sorry, is that, this is, don't drop the mic, but like literally, but, okay.
All right.
Okay, well, I think that's a good note.
Let's keep this going.
Okay, so we're going to do a show of hands now. Everybody, I want to see all your hands. I think we all need some exercise. To answer the question, should you intentionally you, care about little red dots? So, hold on, wait, I haven't asked you yet. Hold on, gotta think. I'm going to go in order of A, B, then C, so get ready. So if you think that, yes, you should care about little red dots, please raise your hands. Wow, okay. Wish I took a picture of this. Okay, B, no, you should not care about little red dots. Ooh, are you too afraid to raise your hand now? Is this like fear-mongering? Okay. C, is it? Okay, fair. I should have had no plot. I'm sorry. Caught, red-handed. Well, sorry, maybe. Okay. Appreciate your honesty. Now, if you go to the next, what I want you guys to do is quickly exercise your vocals, turn to your neighbor for only 1 or 2 minutes, and I want you to justify your answer, please. So, commence. To each other, not to me. You're talking to each other. Where's there? I somehow have this mic. I have the mic. I have like 2 mics. I'm just gonna put it down. No, I know. I'll just leave it here.
What happens next after the
I was trying to remember.
We vote again?
Yeah, do we change our answer? Okay, and then we'll move on. Okay, let's see if you can do your percentages by eye.
I just made numbers up.
Okay. See if we get any. Okay, and then you're going to do the disc one, right? Okay. Oh, you don't want to do any discussion. They can carry it on to the after break. How about that? We'll leave it at that and say, okay. I agree.
I want to go home.
Okay, because we are all ready for today to end, we would like you guys to revote and see if you have changed your neighbor's mind, since you probably said yes and your neighbor said yes, and maybe you changed each other's minds, so let's see. So, if you believe that yes, you should care about LRDs, please raise your hand. Okay. No. Nobody still. Maybe. Okay. I think some of the maybes turn to yes. I don't know. Hard to tell. Okay. Peer pressure. 1,000%. Okay, we have one more poll. Susan. Do you want to read off? No? Okay. Well, what am I? I would like to know, your options are A, I am a disk. This image here, by the way, not me.
The image of Max, are you a disk?
Okay. And B, I am a merger. People are like raising their hands like this. How are we supposed to see you? Thank you. Okay. And C, both. I am a disk and I am a merger. Oh gosh. Is this like my PhD defense again? Maybe we need a better definition of what a merger is. I mean, there are definitions. Well,
They work in the local universe. That's what we're kind of
yeah.
Yeah.
Okay.
We're keeping that short.
So our last slide is here, and we had these small group discussion questions. I think it was a bit of a hodgepodge, I think, of sessions of different interesting things that we heard about. Well, not the LRD. That was really a pretty focused, dense session. But then in this afternoon, and so some of the things that we thought, some commonalities that we saw, building off of our earlier discussion and earlier sessions, were mentions of selection functions in terms of possibly biasing our population studies. And this was, we heard about protoclusters. This also impacts LRDs, defining mergers, disk merger. All of these things come back to selection functions. Something I think that was underlying and not really explicitly talked about, really, but is important, is understanding systematics and assumptions we make when we're modeling and we're deriving parameters from the data, photometry, spectroscopy, in terms of if we're missing, we have certain calibrations. And then finally, from the simulation standpoint, asking the question if we're linking resolutions across cosmic scales correctly. So everyone is tired, and our thought is to stop here and to encourage you to discuss these questions as you go. Possibly that will fail, I don't know, but I feel like we're done and you did a really good job today. So, well done.